Hello, everyone, and welcome to today's Data Center Knowledge webcast. The billion-dollar connection between data center uptime and power quality is sponsored by Micatu. If you have any technical difficulties during today's session, press the Help widget on your player console to receive assistance in solving common issues. If at any time you're having problems with the audio or advancing the slides, simply hit your F5 key to refresh your webcast console. To submit your questions for the speakers, use the Q&A widget at the bottom, and you can also find educational assets available in the resource widget. Today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow, and you will receive an email when it's ready. So let's meet our speakers today. We have Bill Clayman. He's the EVP of Digital Solutions at Switch and contributing editor at Data Center Knowledge, and Amanda Frike, Vice President of North American Sales at Micatu. And with that, the floor is all yours, Bill.
Thank you so much, Magali. You know, a part of me wants to, I wish we recorded our pre-call conversation with Amanda, just because I feel we touched on all of these topics that we're going to have to recreate here in a second. Amanda, I'm excited to bring you in here in just a few minutes. We're going to have a really wonderful conversation. Everybody listening, we've got a whole lot of attendees, and I'm really happy to see some familiar names. Don't be shy. We love interactive audience. So if you've got a really cool question, if you've got a comment, a statement about what we're discussing, pop it in the Q&A. We're going to be keeping an eye on it. Hey, Felix, I see you in there. Thanks for the note. By all means, keep them coming, and we're going to have a chance to discuss this because this is an interesting topic. You know what? Hang on a second. Let me go back to this slide. The billion-dollar connection. Please just remember that title because we are going to be talking about this not just from a monetary perspective. We're going to be talking about this as far as how it impacts data centers, power utilities, the delivery of power, and so on. So let's take a deep breath here. If you've got your coffee, you've got your water, take a sip, because I want to set the lay of the land here for a second. Yeah, right? Data centers in 2020, just digital connectivity. I mean, what a time for us to learn about how important these infrastructures are, these digital infrastructures. And we've seen them to become the heartbeat of the business, which means that keeping them running efficiently is absolutely crucial. And when they go down, unfortunately, we all go down. And that's a huge challenge that we have to overcome. But here's the thing. Did you know that power quality issues is either the leading or one of the leading causes of outages? And there's some really crazy economic numbers behind it as well. There was research done by the Electric Power Research Institute that said U.S. businesses lose upwards of almost 190 billion. That's 190 billion with a B dollars per year because of poor power quality issues. And what we've seen is that with greater situational awareness of power quality issues and harmonics and outages, these challenges can ultimately be prevented. And we're going to talk about that quality, reliability, power innovation. We're going to talk about what some of these leaders are doing in the power quality space to just make our infrastructure simply more resilient. So take a deep breath and let's start talking about you and the data center. I have a chance to work in the data center industry, and it's absolutely phenomenal, and it's super, super interesting, and it never, ever slows down. And a lot of it, obviously, over the course of 2020, we see it 100% speed up as well. And in case you're not, surprised by any of this, I mean, we are firmly in the zettabyte era, and this is something that we're seeing, right? We crossed into the zettabyte era. My goodness, what was it in 2012, right? And today we're firmly in this, and by 2025, you're going to have 175 zettabytes in the total data sphere of all the stuff that we're consuming. And it's because of these things. This guy, my watch, all of these connected devices that are always consuming data, creating data, and always keeping us as productive and as connected as possible. Take a look at that. Digital around the world in 2020. I mean, all of that is only going to continue to increase. The amount of people connecting, the amount of unique internet users, the amount of mobile users, all of that is going to grow. And because of this, the data center is changing. Because of you, because of me, we're seeing more IoT devices. We're seeing more hyperscale data centers being built. We're seeing the average cost of an outage continue to increase. Now, that's the average cost, almost $750,000. I mean, I've worked in environments where a data center was producing, this is a pharmaceutical environment, and this is through an AFCOM conversation. I'm not going to name names, $2 million a day. $2 million a day. And it was because, and I'm sure Amanda's about to super cringe, it was because of power issues. I'm not even kidding. It was because of power issues, brownouts, poor quality. And this organization, they would go down for a day, lose a couple $1 million in revenue. And this was their life because they didn't have visibility, they didn't have good partnerships, they didn't have an understanding of how power quality was affecting their business. So if you take a look at the broader landscape of the entire industry, we just did our State of the Data Center report. My goodness, I think it was like last week. And we found out that the data center industry is fundamentally changing. So more data centers means more power being consumed. So come out, everybody take a look at this chart right here, because this is an important chart. In 2014, that big blue bar was our enterprise data centers. But this was also people who like make ice cream and shoes that also happen to run data centers. We've realized now that they need to focus on what they're very, very good at, which is making ice cream and shoes and not always running data centers. And that's where we've seen this enterprise data center shrink, and that red, that hyperscale, the larger cloud, the multi-tenant spaces increase, consume more power. We've seen them work with more resources. We've seen more organizations large this digital modernization effort go into hyperscale environments. We continue to see that grow and evolve. So that's where we've seen that shift happen in the hyperscale space, in the larger data center space. But that's also where we have to take a little bit of a deep breath and say, how does that change the power equation? How does that change how we consume and absorb all this information? And Amanda, I'm about to bring you in here, and it's a really funny story. Literally this morning, I open up the Daily Herald here nearby, and I read about how in Hoffman Estates, right outside of Chicago, they are going to be building a beautiful 200,000 plus square foot Microsoft data center. And literally the first sentence in the paper was, all right, now how are they going to get the power to it? How are they going to have visibility in the power? How are they going to actually understand what's being consumed? That is actually the biggest challenge, where Microsoft has to talk to the local utility and say, hang on a second, we're going to need quite a few megawatts here. How are you going to deliver all of this to us? Which is where we begin this conversation, and where I'm excited to bring you in, how we in the data center industry are playing an active role with the grid. Now, and I'll start this chat by saying, we at Switch have done some really unique things, right? We are actively, and by the way, I'm not going to be offended if you open up another browser and check out Micatu or Switch, by all means. But we're building something called Gigawatt 1 Nevada, and it is one of the world's largest behind-the-meter power plus solar arrays. It's 800 megawatt hours of battery capacity using Tesla Megapacks, and it's crazy, right? And 555 megawatts of solar energy as well. That's all going to be, created to design and power some of the world's largest hyperscale and exascale data centers. And that's really, really special. But we're also seeing that combination between data center and power providers. I'm gonna take a deep breath here. Amanda, how are you seeing the role of the data center, certainly in the grid, change and evolve? I mean, you are boots on the ground when it comes to power and resource and availability. What are you seeing change?
It's been really fascinating. And it's interesting you brought up that story about Chicago, because when I was a distribution engineer at a utility, we used to get these requests, and they had really funny code names, right? It was like operation, truck or whatever. And it would come in and it would be a request for some major facility. And we had one, and we would bet on who it was, right? And we had one, and the best one was, we thought it was Tesla. And I'm pretty sure it was, when they were searching for their facility that I believe ended up in Reno. And it was, how are you going to get me the power and show me the reliability reports? Right? Because not only do they need massive amounts of power, but they need it to be reliable, because as you said, it's very expensive when they go down. So it's really fascinating to watch as these huge loads come onto the system. Now you have situations like what you guys are doing in Nevada, which is so incredible, where you're not just consuming power, but now you're producing it. And it's becoming this whole ecosystem of, although you're behind the meter, it's not behind the meter how we've traditionally looked at it. You are basically creating a small utility on the other side of the utility meter. And how can we all play together and make sure things are going to be stable, right?
That's a really good point. And we're going to talk about that in just a little bit, the partnership behind that, right? We don't necessarily want to be a utility. That's not our goal. Our goal is to create green energy for hyperscale data centers in the largest capacity possible. So we work with Con Edison, we work with Tesla, we work with Capital Dynamics to make sure that it was funded properly. And that's where we start talking about how it's important to become partners for utilities. Yes. And that's a different conversation all in itself, isn't it, Amanda? I feel like this conversation about sophisticated power systems, including things like UPS, DSIM, and metering, that's where we're seeing the role of the data center evolve. Now, there's one more point in here, your second bullet point, that's really, really important. And I want everyone to sort of internalize this. How data centers are becoming the microgrids and backup power and storage certainly is really important. But what these environments are doing is that they're, how do I say it? They're overcoming connectivity gaps. You know, we have like food deserts, right? Yes. We have connectivity deserts as well. And that's why it's important to understand that edge environments, remote computing ecosystems, and really good sourcing of power to those remote environments is really important. Edge environments are not just like secondary pieces of equipment that you could have out there that if they go down, whatever. I mean, we're talking about healthcare, pharmaceuticals, educational systems, logistics, manufacturing are all connected to these environments. Tell me, Amanda, why do you think it's important for data center leaders to sort of shift their mindset and understand how having good backup power and storage for these smaller ecosystems is so important above and beyond their larger environments? What do you think?
Right. Well, and I think it's so interesting, and we've talked about this offline, and like you mentioned, I wish we could have recorded all our previous conversations because there's so much juicy stuff that I hope we can remember and kind of regurgitate to the group because it's so good, and I think it's such an important conversation. But, you know, when you look at how these data centers are putting in all of these renewables, which, I mean, clearly great for the environment, we want to see that kind of power come on the grid, but you go beyond that, and how good is that for the community, right? Not only are you supporting data for, you know, critical assets in our country, but you're also supporting the community right around it, right? You're creating jobs, you're creating a stable power grid there. And so when you look at things like rural America, where you have the land to build these hyperscale facilities, you know, previously those folks that are living out there may have had unreliable power. And it's not by fault of the utility, it's just what the situation is. And then you put in something like your gigawatt facility, and now they've got this huge, stable source of power that has come because of this data center being built. So it's really just incredible to watch, you know, how can these data center leaders partner with the utilities that are already there to create not only sustainability, but that stability, like I mentioned before, for the community that they're serving.
I feel like you're giving such good insight here. We've got more about this in the next couple of slides. So this next slide, please don't kill me. I know the title says this is the new normal, even though none of us really know what normal looks like anymore. I couldn't remember what day it is, let alone like what is the new normal. So I love all of these bullet points, right? Energy storage will disrupt consumption patterns, and renewables have grown 3x over the last 10 years. And that's 100% accurate. And let me take a little pause here. Remember that title, right? The billion-dollar connection here. I mean, the project that we're working on with Switch is $1.2 billion, right? And we're seeing other renewables absolutely hit the market, right? The multi-billion-dollar project that's being done by Dominion Energy to build, I think it's the largest wind farm off of the East Coast to power some of these hyperscale data centers in Nova, for example. So it is $1 billion conversation, and not just about outages, people, as well. It's about the investment opportunity, and it's about doing something really great for the environment. So we know that energy storage is going to be disruptive, and most of all, it's that renewable element that's going to be part of that disruptive element as well. And we know that digitization is going to fuel economics where, listen, data is the lifeblood, is the oil of our generation, right? And certainly when we have to focus on ensuring things are stable in that element as well to make sure we can deliver applications and data. Obviously, power outages are really, really critical to understand, and businesses lose quite a bit of dollars. And I've seen personal experience of where power can be a massive indicator of power outages. I want to ask you, Amanda, about this new normal, these power quality issues. These numbers hold up. It's very expensive to go down.
Oh, absolutely.
It's also expensive to lose out on business because you don't have power reliability in a certain region. Tell me about how you see this new normal and what it's going to be happening, how it's going to be impacting our economy over the next couple of years. What do you think?
Yeah, it's really interesting. And what I share with people a lot is that the energy industry as a whole is on this precipice of change. Right? Everything is being flipped on its head. Power has flown one direction since its inception. And now we're creating this complexity that is just beyond the engineering that we have at our fingertips right now. And so what's happening is the power quality is something that we really have to take a deep look into. And the complexity of how electrons are flowing and the protection of the system, all of that is changing. And that's where I think, you know, these private companies like Switch and others who are building these microgrids and the utilities have to come together to knowledge share and say, how are we going to make sure that the lights stay on, right? How are we going to make sure that some of the interesting things like harmonics that I know we're going to get to that weren't a problem before are sneaking into the system now? And how are we going to manage that? How are we going to get ahead of it, right? So that we don't see these multi-million-dollar outages in the future. And so it's a really interesting, very technical conversation that just has to happen at this point, or things are going to start going down.
You know, it's really exciting, Amanda. You said something really important, the power discussion. And this is something that is different. Over the past couple of months, I'm hearing stories on NPR, CBS, these just general media outlets that are talking about, hang on a second, data centers? They're talking about power delivery. They're talking about microgrids. I'm hearing this on like my Amazon devices, and I'm like, this isn't something that usually I hear on the news. I had a friend of mine reach out to me recently, and he's like, Bill, did you hear what happened in Texas? I'm like, yeah, it's pretty insane. All those power outages, and he's like, insane. And he's like, and he works in HR, and he's like, Bill, I heard there's data centers in Texas. I'm like, there's definitely data centers in Texas, buddy. And he's like, well, what happened to them? I'm like, how are they affected? And my mind was blown that we were having a power discussion with an individual who would have never brought this up in the first place. And that's the exciting part here, Amanda, is that we're for the first time, honestly, in a broader spectrum, maybe this is the new normal, where we're having a conversation around power, reliability, power delivery, and what it looks like. Everything obviously from California, building microgrids out there, to Texas, to the East Coast and everything in the Central. That's been the really, really interesting point. In your industry, maybe where it's been more isolated, and you're focusing on sensors and power, have you seen that conversation just blow up or broaden out to more people? Tell me a little bit more about that. I'm curious.
You know, you've hit the nail right on the head. I mean, I think part of it is, you know, the politicization of the energy industry, right? There's a lot of kind of this political microscope now upon how we get energy, how it's delivered. Is it coal? Is it solar? Is it biofuel? You know, so there's that aspect I think is bringing it into the mainstream from the political spectrum. But to your point, some of these disasters that are happening, whether it be, you know, Superstorm Sandy or the huge fires in California or the Texas madness that happened, you know, earlier this year, it's people don't think about the power until they flip the light switch and it doesn't turn on. And that seems to be happening more, right? And I think the other thing that's really, really driven the conversation is this, because now when the power goes out, somebody jumps on Twitter and says, oh my gosh, my neighborhood's out, or, you know, hey, whatever energy company, why aren't my lights on, and why is there not a truck on my street yet? So the availability of the news of the power system has exploded, and so now you're totally right. People who were like, what do you do for a living? Why do you have an engineering degree? Now are calling me and saying, hey, I'm thinking about putting solar on my house. What does that really mean? Or, hey, the power went out last week. Do you know what happened? And they actually want to know. Right? And, you know, what are we going to do with all of this stuff coming online? And for me, it's very, very exciting because clearly, as passionate as you are about data centers, I'm equally as passionate about the electrons flowing in power lines. Right? And so it's really fun because now we're finally having the conversations. And like we said before we got online, we're seeing the investment. Like that is what's so huge. We're seeing the investment in the market to really push the technology forward, which is why it's so fun for me to be at a technology company, right? Because now I'm part of the movement. And we're getting to make a change and make the world a better place, which is, you know, a little high in the sky, but it's true. You know, all humans are connected by electricity. It's the biggest machine in the world, right? You know, Amanda, it's so cool.
You're nailing it, right? You're nailing it. We have a saying in the industry: every click improves the future, and it has an impact, right? I remember speaking in front of a group of students. And I told them, like, everything you do on the internet has an impact, has a power impact. Like something happens in a data center where what you've done, it has an impact. And they don't really understand that, right? They'll stream Pandora or Netflix or whatever. And when I say something like, did you know that a single Google search can power a 100-watt light bulb for 11 seconds? They think about it.
I did not know that, but I'm definitely stealing that.
You should. You absolutely should, because that all of a sudden...
That's a T-shirt.
Next time we can do a webinar, we'll put that on a T-shirt. Yeah. But that makes them think. It makes people think, right? Hang on a second. So every time I stream a movie and something's playing in the background, that's consuming power, right? Every click, every stream, everything you do consumes power. And I think you're bringing up some really, really fascinating points here around responsibility, right? And what I want to talk about, we got a note from John here. That is a cool fact, right? But that also brings the physical element of power. Yeah. And our clicks, right? Our streams, our pictures, our swipes, whatever the case might be, into a reality. It makes people just think about what is my impact on the environment. So we talked about this briefly, Amanda. Finger pointing, right? The power's out. Whose fault is it? And that honestly is one of the challenges that we've seen out there. And there's a few other ones as well. I'm gonna talk about this one just a little bit. I love this idea, the ghost in the machine, right? The harmonics element behind various data centers. Talk to me about this slide, right? Different types of loads where harmonics can really give you a lot of information and where you can see some of the problems. I just want you to talk to this. This is one of my favorite slides. Go ahead, Amanda.
Yeah, I mean, harmonics are such an interesting thing because, when you go to engineering school, I'm an electrical engineer by education, right? We learn about harmonics, and then you get out of school and you go work in the utility industry. And unless you're with like the really deep power quality people in the utility, it's not really something that's mainstream, right? It's sort of like, okay, they're there, but they're not a big deal. It's, things get filtered, it's fine. Well, now what we're seeing, because of all of these nonlinear loads, because of all of these interesting things coming onto the grid, harmonics are becoming an issue. And it's something we haven't necessarily had to deal with at this scale yet. And a really good example of this is, because I am the nerd that I am, which I know you share the nerdy sentiment, I was reading papers about electric vehicle charging recently. And, a lot of these kind of microgrids and different facilities, it's cool to put in EV charging. Elon loves it. And so these different chargers are coming in all over the place. Well, it's been found that certain chargers are throwing out the 23rd and 25th harmonic. Kind of random. Nobody knows why, right? So you start digging into these papers and you look at, okay, the more chargers we put, these harmonics are going to start to compound. And then it is going to become an issue because each of those charging stations has requirements they have to meet, right? They can only put out so much total harmonic distortion before they're out of compliance because we know it'll cause problems. But who's monitoring all of those collaboratively, right? Who's looking at all of the different things that are putting harmonics on your system and making sure things aren't going wonky, right? And that's one of the conversations we're having a lot. And I think a few slides down, there's a quote from one of our utility partners who's putting in our sensor product because of our harmonic capabilities. Because what we say is we don't know what we don't know, right? You're not going to know you have a harmonic issue until there's an issue, unless you're actively monitoring it. And I think in the complex, systems that people like Switch are building, is if you have storage and you have solar and you have this data center, there are all sorts of different pieces of incredible technology that have some things, dirty little secrets that they're putting out onto the system. And we just need to make sure that we're able to balance that, we're able to filter those things out, and we stay ahead of it, right? So that we can keep that power quality and power reliability where it needs to be.
That's interesting. It sounds like there's a missing part here that we're going to talk about in just a second. I'm not going to give it away for the audience. I know we're going to talk about it in a second. So in looking at the data center industry in general, there's some challenges that power and data center leaders face all the time. We talked about harmonics. Not all power is the same, right? Data center needs to have deep levels of visibility to power quality. I'm going to build the slide out, Amanda. Bear with me here for a second.
Yeah.
There's other elements here as well, right? So management, without good metrics and visibility, a lot of power, management is reactive, which is kind of scary, especially when you have such a high critical ecosystem. It's not always easy to meet power, quality assurance, reliability metrics. Capacity is a big issue, right? How do we forecast what else we need, how much we need? We just talked about it right now, right? With the Hoffman State Chicago data center that's being built by Microsoft, they're seriously asking the question, listen, maybe you can deliver this power now, but we are planning to expand it out. Can you give us the rest of these buckets of energy that we need a little bit as well? And that's where the conversation gets a little bit complicated as well. And obviously complexity, right? There's a lack of smarter systems means more manual operations and service remediations takes longer. So I want to pause here for a second. You take a look at these 5 challenges. What are you seeing? Do these resonate with you? And which of these do you think maybe is more prevalent than others?
Man, I mean, it's hard to pick a top one, honestly. And what's so interesting is that, it says challenges with power for data centers, but this is challenges with power, period. Right? It doesn't matter if you're a data center or not. Any kind of load is going to experience this. The utility experiences this. And I think it depends on the situation. I think the security part is huge. We're seeing the hacks like the pipeline hack, right? Looking at these different types of security, whether it be cyber or physical, that has been something that has just exploded in the utility industry, is the need for this security, a need for security of the data, and that need for visibility, right? And I think that comes from a couple of different places, from the management, from the complexity of understanding what's really happening on all areas of the grid, right? How do we make sure we're stable? How do we make sure we're resilient? How do we make sure we're safe? And that's really been the challenge that's come forth. And I do want to touch on the capacity, because that's a really interesting conversation. Yeah, that's a really interesting conversation that is bridging some very cool gaps in my world right now. Because, you know, you look at how energy is traded, and, you know, there's a lot of people don't understand that there are folks sitting there at energy trading desks who are trading power like the stock market, right? Power doesn't just flow. There's a whole financial market behind it. And as the grid becomes more complex, we're needing more variable power to help sustain everything, right? So DERs, right, distributed energy resources, which is what we would call some of the plants that Switch is putting in, these resources that are not the traditional large power plants. But it's one thing to put them in, it's another thing to connect them, but really it's how do you manage them? And how do you manage them effectively and keep the capacity correct for the system? And so what we're doing is we're bridging these gaps between the folks in the utility market who are usually more concerned with capacity energy trading and the engineering side. Because it used to be the power just flew, right? It's a coal plant, it's a nuke plant, it's stable, but now everything's becoming unstable and it's becoming variable. And so now we're having to have these, again, very technical engineering conversations in the same room as energy trading conversations, right? And you're seeing systems like DERMS come out, distributed energy resource management system. We're having to control this stuff on the fly. And it's so fast, we're having to have a computer do it, not a human. Right. So that's where this complexity and the challenges, it's just fascinating. And of course, for any of that software to work, you need data, right? And so this is where you and I become connected, because, you know, at my company, we're helping produce the data off the grid. And at your company, you're helping store that data. And so it's all this huge ecosystem where we have to all get together and talk about the problems.
I feel like we're coming in. Oh my God, there's some good questions coming in. Tom, I want to see if I can call that out in a second. Amanda, take a second to read that one before I go to my next slide.
Yeah,
I love the interactive people. By all means, keep coming with those questions. Tom is bringing up a really interesting point around harmonics, and this is where you can shine a little bit, right? He's saying, like, for example, the 5th, 11th, and 17th are particularly bad for motors. Are there any particular harmonics that are more harmful than others to data centers?
To data centers.
Yeah.
That's a great question, you know, and that's something I'm going to have to do some research, because it would depend upon the equipment you have, for sure, and what type of protection you currently have. And that's something, you know, Bill and I, you know, we've talked about getting our technical folks together in a room to really talk about it, because we haven't done that before, right? It's in my world, I'm dealing with 4 kV, 12 kV, all the way up to 500 kV. Where you guys are looking more at the low voltage system within your data center ecosystem. And it's bridging that gap and understanding, how am I affecting you and how are you affecting me, right? And how do we get together and really solve the problem?
I agree with you there, right? And to Tom's point, right, I think this is the first time where we're having some of these conversations where data centers are much more in line. The room that these conversations are happening in are smaller, right? That's, I think, what's happening, right? With more important, more pointed conversations. In the past, we really didn't need to answer that question entirely, right? Where today we're more in line with utilities, whether it's at the grid, the microgrid level, or even the production side of it, where we do have to answer some of these. So, Tom, I'm gonna get back to you on that. I think it's a really, really good question. Amanda, you brought up a really interesting point before this, where the missing piece, one of the biggest important points, and I think you're absolutely right. And here's a really interesting point here. We do have data. We do have information from, like, a UPS system or a PDU or what's within the data center, right? But that's not what you and I are talking about right now. It's a little bit of a different kind of data, where it's beyond data center uptime, but these sensors, these optical non-conductive sensors that when you first told me about them, I'm like, hang on a second, say all of that again, because I don't think I've ever seen something like this. So I really want you to talk about this missing piece in the data center, and really why this is important right now as companies and hyperscalers and even just large data center providers that are working more closely with utilities. Why do they care about this?
Yeah, I mean, the name of the game is really power quality, right? And it's interesting because when it comes to kind of sensor and metering technology, on the power side, we've been doing it the same way for 100 years, right? You're either using an instrument transformer or more recently in history, something like a line post sensor, right? Both of those pieces of equipment are electrical circuits. They are transformers that are transforming power down to a level that metering equipment or relays and controls can handle, right? Because if you put 12,000 volts across a relay, it's going to blow up, right? So those, I mean, we like to blow things up in the power industry, so let's just get that clear.
Oh my God, don't say that to me.
What's really interesting about Micatu, I know, but what's cool about Micatu is we don't blow up, right? And that's where this technology is so fascinating, right? We're coming in with that real engineering mindset of how do we do it better, right? How do we get the data we need, better data even, and make it safer and make it more reliable, right? So what we're able to do is bring in those traditional power quality measurements, whether it be voltage or current. Our harmonic capabilities are amazing. Going out into the power factor, all of those things. But we're able to do it by measuring the fields involved, so the electric and magnetic field, through optical sensors, rather than creating a real electrical circuit. So for all my electricity nerds out there, right, so if you have a current transformer, a CT, one of the most dangerous things for somebody who works at the utility is an open CT circuit, right? Because if you hit that, you're getting zapped, and you're getting zapped hard. We completely eliminate that risk. Right? If there are transients that come across the grid, right? So some anomaly in the power that's going to cause a big problem. If you have a measuring device that is an actual electrical circuit, it's going to feel that problem, right? That problem is going to go through that device and could cause a catastrophic failure. We don't feel the problem in that electrical sense. We just see the field, right? The electric or magnetic field get bigger, do something weird. And we measure it. And then we tell the utility, hey, here's what's happening. So from the data center perspective, what's really interesting is we can say, okay, there's two ways to look at it. One is, let's verify when you are consuming power from the utility, let's just verify you're getting what you need, right? Let's verify the power coming in is clean in the sense of you're getting good power quality, right? And that's how I had always thought of it, is let's verify that, which, they've got standards, and most of the time you're gonna get great power from your utility, unless something is, very wrong. But what we've talked about in the past is looking the other direction, right? And is thinking about, as these data center leaders have, like ESG goals, right? First one being environmental, is, we're building these amazing renewable facilities that are large, right? They are utility scale, and they are providing a lot of power not only to the data center, but also the communities they serve. And so why don't we measure the impact of that? Why don't we verify that it's not only clean from it's a solar field, right? But clean as in, we're giving you really good power. And there's something in the power world called technical losses. So technical losses mean it's power that's being gobbled up by things on the grid, not being used by a consumer, or it's just inefficiencies, right? So the analogy we use in the power space, which is one of my favorite beverages, beer. So if you have a beer, right, there's beer, and then there's foam. Well, the beer is real power, and the foam is kbars. So the utility has to deliver all of that, right? You guys, as a power producer, are delivering all of that. What gets billed is just the beer. The foam is waste. That's technical losses, right? So if we are measuring in your data center, yeah, right? It's great. Everybody go look up the power triangle and just type in beer, and you will get 1,000 Google hits on pictures of beer mugs and power. I know, engineers love beer. What can I say? But what's really interesting about that is that if we have sensing technology like what Micatu provides, right, and we are within the microgrid that Switch or another data center has built, we can verify that we're limiting that amount of beer foam, right? We're giving the utility in that community a good pour. And that's something where we're being more efficient, right? We're not only saving money, which, of course, anyone in business wants to do, but we're providing more good, clean power, right? Clean as in renewable, but also clean as in it's solid power. So it's fascinating. There's so much you can do once you get that data at your fingertips.
So I had a chance to read about these. Yeah, now there we go. Yeah, now, well, listen, we're going to meet up in Arizona at the Tucson Hop Shop, shameless plug.
Yes,
and have ourselves a foamless beer. So you bring up some really good questions, and you talked about this point, and you talked about this a little bit earlier as far as bridging that gap, right? And we've talked about how your optical sensors bridge that measurement gap to grid modernization. Can you talk to me a little bit more about how these optical sensing technologies work, their principles? I mean, for for a hyperscaler in a large data center, accuracy is really important, right? You have to have a large dynamic scale. Yeah. You need to be able to have, you know, how do I say this? Do you remember one of the challenges that we talked about was complexity? If we're going to be introducing a new power technology, it can't be complex. So that's another challenge, right? If I'm going to go back to, yes, exactly. Talk to me about accuracy. Talk to me about some of the range elements here as far as some of the harmonics, and certainly about this. Is it modular? Are these things easy to deploy, or are power leaders in the data center space going to rip their hair out? What do you think?
Yeah, I mean, I think that's one of the most beautiful things that the leadership team at Micatu designed, is the modularity and the elegant complexity of this situation, right? So they've designed a sensor platform that, if anyone in the power industry knows what a hot stick is, it's a stick that you can put things on the power lines while it's hot, right, where you're in power. So our sensors can be deployed hot. You don't have to take an outage, right, as long as you use the right form factor, which is incredible because a lot of the sensing technologies out there require full outages, right? It is an intense construction situation to put in some of this equipment where we're saying, no. Give me a couple of hours and alignment, and I can get you fully connected, right? I can get you all of this data. And when you say accuracy, that's a huge point, right? So we're bringing in 0.5% on both voltage and current, which is solid data, right? That's going to get you to the point where you can do massive analytics, understand your power quality fully. But what's really interesting is the harmonics, because traditional instrument transformers or line post sensors actually act as passive filters. So they're going to be pulling out a lot of that harmonic data. So it's getting gobbled up like Pac-Man before you ever get a chance to see it, right? So what we're doing is we don't do any of that, and we're able to measure it and provide it. So on the voltage side, we actually go out to the 250th harmonic, which as an electrical engineer kind of blows my mind. Because, yeah, I mean, it's like, what's out there, right? We just don't know. Again, we don't know, we don't know. And we've seen, you know, some of this harmonic distortion start to creep up into these really high levels. And it's not something that's been studied super thoroughly yet, right? Because we haven't seen it in practice yet. And on the current side, we go to the 11th. We'll probably double that relatively soon. Current harmonics are more difficult to capture. But in any case, on both sides of the fence, whether it be voltage or current, understanding the distortion that's happening in that power signal is really important, and being able to capture that in an easy way, right? To be able to make a phone call, say, hey, can I get a set of sensors and a crew and be done in a couple hours? You know, that's something we've never seen before. And it's something that we're really excited about at Micatu, because we're able to provide this solution in a really, to your point, easy way, and then be able to integrate into existing software systems, right? So if you've got some kind of an energy management system on the utility side, it might be an ADMS. You know, we use DNP3, which is a very standard protocol. And we're able to send that data back and just seamlessly blend into all of the other data points you already have, right? And then the data experts can come in and say, how do we correlate all this and make it really meaningful and actionable?
That's one of the questions I got in here, actually. I can mark it as trash here, and I can ask you to elaborate on it briefly. But like the integration, it's integration capabilities, APIs, integration with DCM. Can you talk a little bit more about that? I mean, you're clearly talking about the missing piece here as far as data and power and having this really great visibility in this. Everything you're talking about, I'm actually taking notes as you're discussing. So accountability, service remediation, creating this partnership and power engineering around sustainability and greener solutions are all a part of what you're talking about. But I love this integration topic. Talk to me more about that. Are there open APIs? Are there other integration points where you've got with your tools and software? How can we integrate this visibility into data center management?
Yeah, so it's interesting. There's a couple of different ways that we here at Micatu do it, right? So our system has a grid processor at the bottom of the pole or the structure where the sensors live. And there's two different communication paths outside of that. One will be low energy analog. So that's a copper wire where you're getting that stream of data. And that's where you're going to go into something like a power quality analyzer, like an RTU, some type of a piece of equipment that's already in your power ecosystem, right? And that is most likely already connected to some of your other software systems and devices. The other would be this DNP3 data. So that is something that's really standard in the power world, right? You can plug in any kind of radio you want. You can hardwire us in via Ethernet. And then you're just taking those data points and putting them into your software. So it's really about being modular. It's about being kind of agnostic to what kind of software we can play in. And that was on purpose, right? Because we want to be able to serve multiple industries. And that's something I would love to hear from the data center community, because I'm, very much in the power utility side, And although we create a ton of data, I've spent very limited time inside of an actual data center, is understanding what are the communication platforms that you guys are leveraging, and how can, those of us in the power and energy industry that have typically served 99% utilities kind of look the other way and say, what do you need, right? How are you building out your microgrid, and how can we help you? And how can we bridge that gap between the energy systems that the utilities are building and the energy systems that hyperscalers in these large facilities are building?
Mm-hmm. I think that's a really, really good point. We're getting so many interactive questions here. I'm taking a look at the Q&A. By all means, keep them coming. And then Amanda, if you take a look at one of those and you see something that shines out to you, let me know. We can answer one of those pretty quickly.
Yes. And Tom, I love that you said this, because I do want to clarify this point. He says the foam represents the part of the power that is needed for motors and transformers to work. So it's not wasted. You are 100% correct. I was very much simplifying kind of the power triangle, but you're right. In the KVARs, right, the foam has a very important piece into the power system. But for sort of that high level of management of the power versus foam is really something we're digging into, which is really fun. And I'll tell you a little story about kind of that voltage management, because I think it's really interesting. I'm working with a DERMS vendor right now, and we are looking at doing extremely advanced voltage control. And so what they're doing is they're saying, okay, we've got these different DERs on different parts of the system, right, that they have control over as the DERMS vendor, as that distributed energy resource management system. It's a software platform. And so normally they're doing control off of either modeling, which is data, right? Or they're doing off of maybe, kind of top of the circuit, top of the system information. And we're saying, let's go deeper, right? Let's get into that ecosystem. Let's put sensors out on that circuit. Let's put it within your microgrid to understand what's the voltage doing, not just at the top and not just at the bottom, but everywhere in between. And let's make sure the KVARs are balanced. Let's make sure the voltage is stable. And by using real-time sensor data, we'll be able to do this really advanced voltage control and do it on the fly, right? Mm-hmm. Which is really amazing. So they'll be using quad inverters to manipulate the voltage coming out of all these different places in order to create this just amazing power quality and stability that, 5 years ago, we would have gone, you're crazy. So it's really amazing to see the convergence of technologies, which is something I really believe in, of, our sensors are great, these software systems are great, data centers are great, right? But when we converge, we can exponentially innovate. And I think that's where we're at right now. And that's what's really exciting.
And I think you brought up the perfect segue into our next conversation, the partnership, the converged partnership, right? You said it, and I think it's great. So again, and by the way, Tom, kudos to you for continuing the beer analogy. That's really good. Let's keep those questions coming. I do enjoy this, the folks that are being very interactive. By all means, Amanda, take a look at some of those questions. We're going to get to them in just a second. But creating that better partnership between data center utilities, I mean, we absolutely believe that needs to happen, right? As an organization that helped build one of these larger these power systems, these behind-the-meter systems, we're absolutely setting sort of a path for the rest of the industry to see what's possible, what organizations can be doing. Yeah. And you can see just how creative people are getting with their data centers. I mean, heck, we had Microsoft and Project Natick throw a data center 120 feet under the water and found that it had an eighth of the failure rate as opposed to what it was running on land in a similar sort of tested environment. I mean, we're really, really great and creative in terms of what we're doing, right? We see how Japan has the most floating solar island panels. I mean, literally they're in the middle of a lake. They're just giant solar floating panels, and you can collect energy and you can do some really cool things in there. So there's partnerships between technology vendors, data centers, and certainly the power and the utilities vendors as well, and the technologies that are all sort of a part of it. Now, getting started, right? We've got a lot of people here, and first of all, they're asking you really great questions, but there's a whole bunch of folks here in the data center space as well. Getting started with some of these technologies, in my experience, start small, POCs. You've got these sensors. They are, as you put them, non-conducted optical sensors, which just touch on that in just a second, a little bit more for me, just to why it's easier to do a proof of concepts with those. And one of the bigger things I feel is really important to involve business, IT facilities, and utilities, right? Talk to business leaders about power quality, why it's important to stay up, why it's important to have this data visibility into how your power is streaming to both primary locations as well as remote ones, and most of all, how do you strategize for the long term? I mean, literally, we just talked about this. There's a Hoffman Estates example with Microsoft. They're talking about, great, we can do this today, what happens in 2 years when we need to expand, or 3 years, or when we need additional buckets
Yes.
of power? What happens then? Talk to me about getting started. Talk to me more about this non-conducted optical sensors. What does that mean? Why is it easier to test some of this stuff out?
Yeah.
And maybe talk to me about some of these getting started points.
Yeah. So I'll start on kind of the sensor side, right? Because that's sort of my world right now. Is because we're non-conductive, because we're not, passing electrons through our sensors, it's just a really safe solution. And it's something that can be deployed really easily, which is great for point one of starting small and smart, right? If it's something where, you're a data center facility and you're going, we've had the power quality conversation, but maybe not as deep as we think we need to. Maybe we want to start that conversation with our utility and bring some data to the table. Do a proof of concept. It's not a huge investment, right? It's not a huge resource strain to do this. And we have experts that can help you. So, we have a pilot process that we use with utilities, which would be completely identical to what I would do. Let's say if I went with Switch, right? Is let's put in a set of sensors. Let's make sure the data makes sense and is valuable for you, right? Because the last thing I want to do is have somebody invest in something that doesn't make sense, right? That's not good for anybody in the industry. And I think point number two of involving the stakeholders, I think that is probably the biggest miss I see in most technological deployments, is that folks don't bring everyone to the table in the beginning. And sometimes it's because, IT might be a roadblock, or, this group might not want to do it and might hold us back. But I will tell you, from deploying thousands upon thousands of different devices, just bring them all in the beginning, right? Because you're going to hear points of view, you're going to hear strategy that you may miss. And it's just so important to understand not only what's your goal as the person who's thinking of this deployment and maybe sponsoring that proof of concept, but how can we leverage different value streams, right? So this part of the data might be important for me, but this part of the data could be important for you, right? And that comes to point number three of strategizing for the long term, of looking at, okay, here's where my data centers exist today. Here's how my microgrid operates today. There will be technologies deployed in 10 years that no one's even imagined yet. Right? I look at when we wrote the smart grid deployment plan in California 10, 15 years ago, half of the things we're deploying now were literally not invented yet. So I think understanding that we don't know what we don't know, strategizing for, okay, what are the trends of the data center? What are the trends of our power consumption? What are the trends of the utility we're working with? And having those really important conversations and laying out the groundwork is extremely important. And I think as, someone who's on the vendor side, but also just extremely passionate about the energy industry, my kind of life motto is building a responsible energy future, right? Mm-hmm. Is how can I help broker that conversation, right? How can I sit with the Switch executives or any sort of hyperscaler data center executive and say, how can I help you? What do you need? Who do you need to talk to at the utility, right? And then turn around to the utility and say, hey, I've got these really amazing people over here who are building this really amazing system. They need a little help, right? Can you help them? Can we have a conversation? Can we converge these conversations and make sure we're doing it the right way? And let us bridge that gap. And I think that's where we're going to see just some really powerful conversations, some really incredible engineering happen, right? Again, it's that convergence of technology, that convergence of brainpower. And so start small, right? Get the stakeholders involved and build a strategy that makes sense.
I think you bring up a really good points, and we've got an interactive crew here, so I'm gonna open up for questions. Thank you for everyone. Oh my goodness, there's a lot in here. Amanda, you're gonna have to help me out with some of these. There's some good technical ones.
I love all of this.
Let me. Is there one that you like the most?
I like John's question. So does this apply if and when backup power is needed or running, or is that different? That's a really good question and adds a piece of complexity, right? So depending on what your backup power is, that's part of it. Is your backup power playing in the energy market? There's a financial piece of that. And that's a conversation that's been fascinating lately, which is, there's assets out there in the name of backup power that have EPA regulation upon them that they can only be used for emergency power, right? So it's not something that you could just kick on for fun. It's a diesel generator behind a hospital that it's only going to go when the grid goes out. Well, now what we're seeing is, in the name of stability and capacity, we need to be able to have those assets available in non-emergency terms for what the emergency was previously defined as, right? So it's not necessarily that meter went dark. It's something else is happening on the grid, and we really need that power. And so it's adding this, again, this layer of complexity about how we're operating, and then the financial implications of, are you just backup power, or are you an active participant in the energy market now, right? And how are we going to meter that? How are we going to measure that? And that's where, again, I get very excited, clearly. But where additional sensors on the system make sense is because we're adding more data, we're adding more information, we're adding more power. We got to make sure it's all flowing right. So, John, great question. Totally depends on the topology of your ecosystem. But if you have a specific example, email me because I love this stuff.
There's a follow-up question here, Amanda, really related to what John's asking. What are some of these uses for these technologies, and how can they be applied, and specifically the data center and hyperscale leaders? Now, we've talked about, maybe you can reference this, accountability and things like service remediation, right? Talk to me about that. Where do you think these can be applied?
So good. So, one thing, I used to be a utility engineer, right? And so one of the things I did was if, the Qualcomm plant in San Diego went down, we would get a very angry phone call of, we're down, utility, what did you do? And the response would be reactionary. It's, let's put out some kind of a sensing technology for a week or two, and then you'd have an engineer like me analyze it and say, no, nothing happened, right? But that's probably not the case, because hopefully the bad thing didn't happen again, right? And so investing in something that's a more permanent installed sensing capability that has this extra layer, right? It's not just a fault indicator. It doesn't just say the power's on or off, right? We're giving you extremely detailed information about the quality of that power. It's really like a risk mitigation effort, right? It's a liability thing of saying, we know all the time exactly what we're getting and exactly what we're giving. And if something happens, we can go back to that data and say, okay, what was going on? What really happened? Which direction did this come from? And I think from the data center leader perspective, for me, if it was my facility, that would help me sleep at night, right? Is knowing that I've got eyes on the power that I'm getting and giving, and knowing that if something bad happens, we're going to have visibility into it. And then the other thing that I liked that we've talked about offline is that you're building these huge renewable plants, and you're getting the investment to do this, even faster sometimes than some of these utility companies, right? And being able to have real-time data of what you're giving back to your community, right? In my mind, I'm like, there's a ticker on the website that says, right now, we're powering 27,000 homes in Nevada, 38,000 homes in Nevada, with our power. And it's a real meter, right? And it's real data. And being able to give eyes to that for the community, because again, to your point, normal people, right? Not the nerds that are normally in it, normal people care about their power now. And being able to really vocalize what's going on, it takes technology that can see the grid. And that's where we fit in. And that's why we're so excited.
It takes technology to see the grid. That should go on a t-shirt. Good job, Amanda.
Oh, I like that. That just kind of popped out. That's a good one.
I think it's a good one. Oh, Greg says, so much great information. Yes, this is being recorded. And yes, you are going to be able to see this a little bit later. Thanks, Greg. I'm gonna mark that one as seen. Amanda, keep taking a look at these questions. There's a few other ones coming in. What do you think about that DC?
Oh, I was just going to say, Matt, your question about DC is fascinating. So I will totally admit, I have not worked with a DC data center. We do have the ability to measure DC power information. So if you're up for a conversation, I would love to invite you to a Zoom date, because I think that is something that's going to be really fascinating going forward, because the DC world is something that, as far as kind of power utility engineers are concerned, and I'm just speaking from my own experience here, but we don't talk about it a lot, right? You see these super high voltage DC lines that run, multi-state to get power, transmission going, but we don't play in kind of this DC ecosystem that you're speaking to. So I would love to dig into that. I think that's another one, kind of like what Harmonics might be trouble for some of the data center equipment. That's another one I think that deserves some more conversation.
Very cool.
You guys, this is so fun. I don't know that I've ever had a webinar with so many questions flying in like this.
It's because we told people we like an interactive audience. So please keep them coming. We're going to try to answer as many of these as we can. Amanda, as you're looking through this, I wanted to ask you one here. If there's one thing you could share with the utilities, what would it be?
Oh, I think we both need to answer that question.
I think so too.
So Yeah, I think for me, it's, speaking as I say I got utility blood, right? I started my career at a utility. I still say we when I talk about the utilities I used to work at. If the power goes out on my street, I literally walk up and make sure the fuse cutout isn't blown, right? I am a utility girl. For me, it's pick up the phone and have the conversation, right? If you're concerned about something that's going on, don't ignore it. Call the guys at the different companies that are supporting the data centers. Get on webinars like this that are not on the typical utility platforms and see what people who are building these microgrids are talking about and offer your expertise. Guys, we utility engineers, we've been serving the power for 100 years. No one knows this stuff better than us. So come to the table and share your knowledge, right? Come outside of your comfort zone. That's what I would say.
You bring up a really good point, Amanda. And from a data center perspective, hyperscale, it really is a partnership conversation. It's sometimes contentious, sometimes challenging if you want to leave a utility, for example, and you want to develop and deliver your own power solutions for data centers. But you can't create a partnership. There's a lot of investment that's happening out there, specifically designed to focus on that ESG, the E part of creating a more green environment out there. And just to kind of point this out, it's really for the first time everyone in the industry is putting their money where their mouth is, right? Where organizations, board of directors are directly compensating leaders in the data center and energy space on their environmental and their green efforts, to the point where they understand that these are going to be profitable solutions. So when we start to talk about utilities and we start talking with utilities, it is that partnership conversation. How can we deliver these power solutions? How can we deliver power elements of reliability? How can we help organizations modernize their power solutions so they can build, grow, be more reliable? I don't know if I can add anything else, Amanda. I think it really is a partnership conversation. Yeah.
Yes, I couldn't agree more. I mean, I think if there's anything you get out of this, besides the fact that Micatu makes incredible technology, right? Shameless plug, but is really that partnership, and understanding that it's going to take all of us to take the power system to where it needs to be to serve what's going to happen in the future. And the sooner we start having these important conversations and making that small room we talked about bigger and bringing more people to the table, that's when we're really going to move forward. And that's where the real innovation is going to start to happen. And it's so exciting.
We have time for a couple more questions here. Mitchell, I see you in there. We'll try to get you in just...
I like that. Yeah.
Go ahead.
Do we want to take that one? Sure. So Mitchell's asking about DC battery energy storage systems. So batteries are really interesting. The battery technology has come so far in several years. I think it's still got a long way to go. It's in Arizona. We lived through a very unfortunate event with a utility scale battery system. You can look it up. It was just bad. It blew up. And so I think from a battery perspective they're going to be an incredibly important piece of the grid, but monitoring them clearly will be even more important. And how are they going to play in? How are we going to make it safe? And I think to the point, that Bill, that you made earlier, kind of about the ecosystem and how it's all working together, is making sure we're driving value out of every single piece. And I think that's, again, that partnership, right? Because the second you leave the grid, the utility grid as a microgrid that's completely disconnected, you're no longer able to provide some of those amazing benefits back to the greater good. Right? So there's things, frequency stability and capacity control and different pieces of value that you can bring with some of the advanced equipment that you're putting in, that we lose that now. And so, again, having that conversation and being a good partner, whether it's, DC batteries or anything else, it's just, again, have those conversations. And if you need help brokering them, call Bill and I, because clearly we love this stuff.
I feel like we could go another 30, 40 minutes or even an hour about this. I mean, we've got more questions here. And as far as battery technology is concerned, right, what we did at Swish with our 800 megawatt hour battery capacity, we waited for Tesla, right? We waited for the mega packs. We waited for the technology to be out there to support the requirements that we needed. And again, we power with Con Edison and Capital Dynamics and Tesla to build these kinds of ecosystems. So they're out there. They're going to be making an impact. And I agree with you, Amanda, 100%. The technology behind these batteries has come a really long way. We don't have any more time for questions. Anything we didn't get to, I promise we're going to get these questions over to Amanda, so you're going to get a chance to ask them offline. Hey, Amanda, talk to me about this additional resource that people can download.
Yeah, so available today, we've got a wonderfully written white paper by some of our team that talks all about sort of the power quality implications for data centers specifically and how these microgrids are evolving. So I would invite you to check it out, download it, read it. I'm an open book. I love having conversations about this kind of stuff. So truly, find me on LinkedIn, hit me up, send me a message. Let's jump on the phone and let's continue this because this is great, Bill. Thank you so much.
I agree, Amanda. Hey, don't be shy, people. Connect with us. I hope that my LinkedIn and Twitter is being blown up by amazing new friends. And let's continue this power conversation. Amanda, thank you so much for joining us today. This has been a really, really wonderful conversation. I certainly learned a lot. Definitely. Magali, let me pass it back to you to wrap it up for us.
Thanks, Bill and Amanda, for the informative discussion, and to Micatu for sponsoring today's event. Just a quick reminder, the seminar will be available on demand starting tomorrow, so please feel free to come back and review. Have a great day, and thank you all for attending.